Dear students, I want to start the differentiation and integrations, which is used for classical mechanics. Differentiations. See, you know that plus, minus, division, multiplication, these four are algebraic operator. Algebraic operator means what? Suppose this is a number, suppose 30 and 40. Okay. If you use this plus symbol, that will give you 70. And use this minus symbol, this is given minus 10, like this. Similarly, for division and multiplications. Similarly, differentiation means d by dx, d by dy, d by dz, d by dt, d by dk, etc. These all are called differential operator. This is called differential operator. Okay, this differentiation, another name is also called derivative. This is differential operator. Like this is the algebraic operator. This is differential operator. This differential operator is operate on a function. Let operate on a functions. Let y is equal to function of x. Then that function, y is a function. This differential operator now is going to operate on these functions. Suppose after operating, you can read this one dy by dx. That means in which we will read this is differentiation of y, differentiation of y with respect to x. Similarly, suppose dy by dz, you can read differentiation of y with respect to z. dy by dt, you can read this is differentiation of y with respect to t, like this. Okay. So now, first of all, you think that what is the use of differentiation and what is the definition of differentiation? There are two questions generally in your mind. What is the use of differentiation and what is the definition of differentiations? Okay. So first of all, I want to tell how this operator operate. After that, I will tell the use of differentiation and definition of differentiations. Say y is equal to x square. Okay. Y is equal to x square. Here y depends on x. Y is independent variable, and x is dependent variable. Sorry, x is the independent variable. X is independent variable because y depends on x. X is a independent variable and y dependent variable. Because see, here y depends on x. Suppose you put x is equal to 1, you will get y is equal to 1. X is equal to 2 square, y is equal to 4. X is equal to 3 square, y is equal to 9. X is equal to 4 square, y is equal to 16. See, by changing x, you will get y. Therefore, y depends on x. Y is a dependent variable, x is independent variable. Okay. Now, say x changes to x plus delta x. Delta x is a small value of increases to x or decreases to x, whatever you think. Here x plus delta x. Delta x is a small change of x which is added with x. As y depends on x, x changes to y changes. As x changes, so obviously y changes. So now y becomes y plus delta y. Now the above equation becomes y plus delta y is equal to x plus delta x whole square. Then what is the value? This is x square plus delta x square plus 2x delta x. Now y plus delta y minus y is equal to x square plus delta x square plus 2x delta x 2x delta x minus, in place of y you will write x square cancels. This side also you will get delta y is equal to delta x taking common, you will get delta x plus 2x, then delta y by delta x, this will give you delta x plus 2x. In the mathematics, another you can say now this is another mathematical engine or mathematical transformations, mathematical you can say operations, that is limit is another mathematical transformations. Limit delta x tends to 0 approaches to 0 means delta x is nearly equal to 0, may not be 0. The delta y by delta x, this is delta x, this is dy by dx, differentiation of y with respect to x. This here d by dx is an operator, differential operator on y, which is equal to limit, if you this side also limit, LT is limit delta x tends to 0, delta x plus 2x. So as delta x is nearly equal to 0, in addition, though some 0 added with some numbers, almost nearly equal to 0 added with the numbers, means this becomes a number. 100 plus 0.01 is 100 almost. Similarly, as delta x tends to 0, it is almost 2x. So dy by dx you will get 2x. You will get dy by dx 2x. You have started y is equal to x square. You will get now dy by dx is 2x. What do you mean by that? When y is equal to function of x, y is equal to x square, then when the differential operator operate on this y, this will give 2x. Yes or no? Y is equal to x square, function of x. When that will operate on function y, this will give you 2x. So I want to give you now some formulas for some formulas how the differential operator operate on a function. Some formulas. So one formula is when y is equal to x to the power n, the d by n is a number, natural number. You can say integer, plus value, minus value, all are allowed. 0 also allowed. Integer you can say d by dx y. The result is, that means d by dx of x to the power n. This will give you nx n minus 1. This is one formula. Okay. By this formula, see, now we'll go to the same question. Suppose y is equal to x square. If we put d by dx of x square, though by this formula, in place of n is 2 is there, 2x 2 minus 1, this will give you 2x. See, this is differentiation. Okay, this is differentiation. And suppose, let another example, y is equal to suppose x to the power minus 3, the d by dx of x to the power minus 3, x to the power minus 3. By the formula nx n minus 1 minus 3 x minus 3 minus 1. This will give you minus 3 x to the power minus 4. Suppose now y is only a number, not a function, means y is only a number, y is equal to suppose 100. It's only number. So how will say y is a function of x? So you make it y is a function of x. So therefore 100 into 1, or you can write 100 x to the power 0. Like this you can write. Okay. So d by dx of y, in this case d by dx of 100 x to the power 0. Any number is not operated by differential operator. This is why it is taking outside. Any number. Differential operator will not operate on any number alone. So therefore the number is taking outside. So then d by dx x to the power 0. Then 100 into 0 x 0 minus 1, as 0 is there, the answer is 0. Another formula I will get when y is equal to constant or a number, y is equal to constant or number. Constant is you can in book it is written C. So then dy by dx is equal to 0. This is one concept. Dy by dx is equal to 0. Or another concept, when y is equal to a constant times x to the power n, then constant is taking outside. Dy by dx is taking outside. Then h is equal to nxn minus 1. Another formula. Okay. So after that, see, suppose y is equal to x to the power n plus x to the power m plus or minus x to the power p. So then dy, in case of addition and subtractions, the dy by dx nx n minus 1 plus or minus mx m minus 1 plus or minus px p minus 1. Then the question in your mind, what is the use of differentiations? Then what is the definition of differentiations? What is the use of differentiation? Generally, differentiation is used particularly for physics. Instant value you will get from average value. Instant value, velocity, instant acceleration, instant momentum, instant force, instant work. You will get from the average value. Means suppose average value of speed you know, then you can get instant value by the help of differential operator. Average value of momentum you know, you can get instant momentum by the help of differential operator. Okay, this is the use of differentiations. Next video I will show you the next one. Okay.